Welcome to NEXTED by Nexaspaces. In this two-part series, we're diving into the world of ESP microcontrollers. In Part 1, we'll explore the ESP8266, a budget-friendly, Wi-Fi-enabled microcontroller that has changed the face of DIY electronics. Whether you're a student, hobbyist, or professional, this guide will give you the foundation and advanced skills you need. Let's get started. The ESP8266 is a low-cost microcontroller developed by Espressif Systems. It features a 32-bit processor running at 80 MHz, with built-in Wi-Fi, and 160 KB of SRAM. The most common form factor is the Node MCU, which breaks out the ESP8266's pins for easy prototyping. Why is it so popular? Simple, it combines low-cost, wireless connectivity, and ease of use. You can create everything from smart lights to IoT weather stations using this tiny board. To get started, download and install the Arduino IDE. Then, go to Preferences and add this URL under Additional Board Manager URLs. https://arduino.esp8266.com/stable/package_esp8266com_index.json. Next, open the board's manager. Search for ESP8266, and install the latest package. After installation, plug in your ESP8266 via USB, select the correct board type, for example, Node MCU 1.0, and choose the appropriate COM port. Now, let's upload a simple Blink sketch. Go to File, then in Example select ESP8266 and Blink, and click Upload. After a few seconds, you should see the onboard LED blinking, and just like that, your board is ready. Understanding GPIO pins is key. ESP8266 has 17 GPIOs, but not all are usable. Some are reserved for boot and flash functions, such as GPIO 0, GPIO 2, and GPIO 15. Analog input is limited to a single 10-bit ADC pin. Also, note that Node MCU pin numbers like D1 or D2 correspond to different GPIOs, for example, D1 is GPIO 5. Be careful when using GPIO 0, GPIO 2, and GPIO 15, especially during startup. Incorrect wiring may prevent the board from booting. Connecting to Wi-Fi is easy. Include the Wi-Fi library, and in your setup function, write Wi-Fi.begin, your SSID, your password. While Wi-Fi.status equals WL_connected. Delay 1000. Serial.println, connecting. Serial.println, Wi-Fi.local IP. This code will attempt to connect to your network and print the local IP address. Now your ESP8266 is online and ready to send or receive data. Let's build a temperature and humidity logger. Connect a DHT11 sensor to GPIO 2. Using the DHT library, read temperature values and send them to ThingSpeak using an HTTP GET request. You can also visualize the data in real-time dashboards. This teaches how to collect sensor data and transmit it wirelessly to a cloud server. Create a web server using the ESP8266 web server library. Your ESP8266 will serve a simple HTML page. From a browser, you can toggle an LED on and off by accessing its IP address. This builds your understanding of embedded HTTP servers and real-time control. ESP8266 supports OTA, over-the-air, updates. This means you can upload new code wirelessly once the device is deployed. It also has a deep sleep mode, ideal for battery-powered applications. You can reduce current consumption to just a few microamps. However, the ESP8266 lacks Bluetooth, has less memory, and is single-core. If you need more power, stay tuned for Part 2. That wraps up Part 1. You've learned the basics, set up your development environment, connected to Wi-Fi, and even built real projects. In Part 2, we'll cover the ESP32, with Bluetooth, multitasking, and more advanced capabilities. Be sure to like, share and subscribe to Nexaspaces.